Yeah. Oh, at least you don't seem nervous.
Oh yeah, it's not joking. I'm just thinking that it's not a lecture, it's a presentation. That's how I'm gonna go.
Oh, lectures are easier than presentations.
Is it? This is my first lecture. I'm like, okay, cool. Just don't show it to people that you're not.
Okay, everybody, let's get started. Welcome back. Today we'll have a lecture on maps, how we build maps in D3, and also a little bit with Google Maps. There will be a dedicated lecture on the kind of like theory behind maps that we'll be talking about in the second half of the semester. And the lecture today will be given by Tripti. Tripti is a PhD student in the School of Computing, and she's doing her TA duties here with us as part of her teaching menteeship. And teaching menteeships have the distinct privilege of getting to lecture. So depending on how long Tripti takes, she will just like wrap up the class, or if there's still like more than, let's say, 20 minutes left, I'll take over and teach more about marks and channels. Before we do that, just an announcement, I won't be here next Tuesday, so there won't also be office hours, but lecture will still be happening. Any administrative questions? Great, so I'll hand it over to Tripti. Take it away.
Thank you. Hi, so today I'm going to talk about, can everybody hear me properly? Yeah, cool. So today I'm going to talk about the D3 maps, how you're going to do visualization on maps using D3. So what are maps are used for? Maps are basically used to show some spatial data and the trends of that data on maps on some spatial domain. So but we'll have a theoretical lecture, as Alex said that. I'm not going to talk about what maps are and why maps are being used. But before you actually build a map, one thing that we need to really think about is that do we actually need maps? So because, for example, because they're very overly used, because, for example, let's say you have some kind of a data of some states of US, and you already know their spatial position. And suppose you want to show that a trend of that of certain data over a time period, but if you try to show it on maps, you just limit yourself to show the visualization, because you don't really need the spatial information, as you already know where these states are. Mostly everybody knows where these states are on the map. So maybe you might want to use some other kind of visualization to show what the data trend of these different cities or states. Nevertheless, let's move forward and see how we can use D3 to show such visualization. So we have two different approaches. One is the data maps and other is the street map. So the data maps are used to present the data on an abstract map, and we can create the different countries and the state boundaries using the D3, and we can show these boundaries and these countries. On top of it, we can show different data trends and communicate how these data trends can affect like maybe can show what data is being communicated over these boundaries and states that we are creating. We can show different colors of visualization on these maps, but the problem with data maps is that we cannot zoom in, zoom out on the maps, and we are just limited to whatever map that we have drawn on the screen that we are doing. Then we have street maps. Street maps are something like we use in our different apps, like maybe a Uber app will be using a street map, or just a Google map will use street maps. And we can use Google Map APIs to show the street maps. And on top of it, we can use D3 visualization to show our data on these street maps. The one advantage of using street map is that we can zoom and we can pan over to see how the data is from a closer view. But they're a little complicated. So it's because it's the street map, and on top of it, you're doing D3. So it makes it a little complicated, and then you need a Google Map API keys to do it. I'll show you how to do the street maps and data maps later. But yeah, that's the overview of data maps and street maps. Yeah, let's get started with what data maps are. Let me show you some examples of how data maps will look when we do a D3 visualization on these data maps. So this is visualization of flu spread through from, can everybody see the screen? Let me just see. Yes. So this is the spread of flu over a time period from October 1 to 7 of 2017 to February 11th to 17, probably be 2018. So as you see that we have a trend, and we show that how the flu is being spread over different states of US over a time period. Can anybody explain? So this is a bad visualization. Can anybody explain why this visualization is not good? Yeah.
Because many small maps have format or something.
Sorry?
You can have a slider and just combine all of these into animation or something.
The colors
Yes.
used for the small cities are not actually differentiated by the color.
Okay, maybe. Any others? Yes.
It's using one color instead of having the whole area be set up.
Okay. Okay, yes. Mhm. Yes. So yeah, as I told before we started this lecture that maps are being overused. This is the example where maps are being overused because we can maybe we do have this trend and we can use maybe some other visualization to show this trend because in this case we have a lot of different maps and we are just showing that trend how it changes from one time to like from October to February. So yeah, we can have some other visualization because maps do show spatial information here, but we can still have some other visualization, maybe just maybe a line of different states can be used here, line graph to show if let's say we have a very simple visualization we want to do. So yeah, the maps are being very overused here, so it's a bad visualization to look at. Okay, let's look at some other example, maybe this one. So this shows the number of bars that have outnumbered the grocery stores in different countries. So as we look here, this is the map of US and it shows that the number of bars in US is more in the Wisconsin area, and other states still have a lot of other grocery stores rather than bars. Yeah, so it's just a zoom in version to show the same thing that I'm talking. So you see that the Wisconsin has more bars, 2.7 times bars as grocery stores. So here are different countries that, let's say, for example, we take France. France has more number of bars, about 81% more than the grocery stores in the country, whereas Germany still have a lot of grocery stores than bars. Okay. Okay, before I go tell about more about D3 visualization, how we're going to use D3 on maps. Any questions till now? Cool. So let's start. So we to do the D3 D3 map visualization, we basically need to we basically use two different JSON format, or the geographic data, that is the GeoJSON and the TopoJSON. So what is GeoJSON format? So GeoJSON format describes the contained geography as a combination of latitudes and longitudes. So it consists of different objects. For example, a point consisting of latitude and longitude. So we can also have multiple points, which will again have a combination of different points with latitudes and longitudes. Then we can have a combination of these points to form a line string. Then we can have multiple line strings, of course, and we can make polygons out of these line strings. Then we can have these polygons and these objects basically combine in a geometry collection. And these geometry collection, which consist of all the points, lines, and polygons, everything, can be used as something called a feature, which can be used to show the properties, which can be extracted in our D3 visualization with something called a property. And we can define different properties in the feature. Like for example, here we have given the property as name, and we can use this property in our D3 visualization of maps. Again, we can have a collection of these features with different properties. Like here we have name and addresses as well. Okay, so can anybody tell if what is the problem with the GeoJSON format? Okay, So the GeoJSON format has a lot of longitude and latitude information. Let's say we are creating a map, and for these map, we need to have the boundaries, the borders, and these borders will share the latitude and longitude information. This will be a lot of redundant information that we have, and we might not want to use GeoJSON that much. So that's why we use TopoJSON, which basically tells the topological geospatial data information. This information is basically stored in a form of shared line segments that is called arcs. And these arcs consist of positions of different latitude and longitude information. So I was just maybe curious to look at what TopoJSON was doing. So I went through this to see the specifications. And in this arc information, it's basically consisting of the value in an array of arrays of position. And these positions are basically calculated using different formulas. So the first position is just a normal position that you can say. Then the second position is calculated based on where the first position is using the formula here. And then these arcs will consist of positive and negative numbers. So you can have 0 that refers to the first arc, 1 that refers to the second arc, and so on. You can also have negative numbers. So -1 refers to the reverse first arc, -2 refers to the second reverse second arc, and so on. So this is the kind of information that is stored in your arc of the TopoJSON. Yeah. So the TopoJSON consists of the topological information, you can say, or the position of with respect to your latitude and longitude, with respect to the data that you want. So instead of having the latitude and the longitude information, we have these positions saved. Yeah. Yes, the position, you can say more specifically. Yeah. Yeah. So we have one first arc, which is the kind of a source, you can say. And after that, it'll be relative to the first. That's what I felt from this, because it says that the second position is calculated using this formula, which is dependent on x1. So I think that they're dependent on each other. So it's the relative position, you can say maybe. Yeah. Okay. Cool. Yeah. So we have this TopoJSON format, which we're going to use, but D3 still uses GeoJSON. So we need to have a library that will take this TopoJSON and convert it into the GeoJSON format that is required for our D3 visualization. So this is the library that we use. So you can extract the features from the TopoJSON format into the GeoJSON using this TopoJSON.feature, and where you will pass the TopoJSON file that you have and the object that or the feature that you want to extract. So basically the object, you should say. So the object here, for example, let's say we want to extract the US state from the TopoJSON file, you can use TopoJSON.feature with the TopoJSON format that you have and the objects of US state. And then you can save it in a GeoJSON format, the GeoJSON that you have, and then you can extract whatever feature you want from the GeoJSON that you have obtained. Okay. So till now we have GeoJSONs and TopoJSONs, but we still need to, we have a lot of information in this JSON format. We still need to show it on our 2D screen or the small screen that we have. So for that, we use projections. So what we do is we project our whole JSON file on our 2D screen. How do we do it? Let's just directly look at the example first. Here. So let's say I have an SVG. We're going to select an SVG, and we are going to calculate the width and height of this SVG. And then we are going to do projection on top on this SVG that we have using the functions that we have, like a geo albor USA. So it's gonna do the projection of the specific to USA, and this projection basically consists of the Hawaii and the Alaska region as well. So once you have that, you're gonna position it on your screen. So the position is calculated. So we have put it on the center of the SVG, so which is basically half of width and half of height. And once you have that, you can position the projection of the data that you have here, that is the longitude and latitude, and then you can just put it on your SVG. Let me just show you how it looks. So you see here we have this small little X on our SVG. Let me just inspect and show it. So you see here, even still the object has the latitude and longitude information. I think it's visible, right? Cool. And still the projected position is on the screen, which is this 582 point something and 287. Any questions here? Oops. Yeah, so we can have different projections that are available in D3, like these are provided here. So you can use based on whatever is your requirement. Let me show you some projections in D3 that has been shown already available. So you see here, we have this projection. We have the same data, but it's been projected in different shapes. And you see how this data in different projections, how different it can look in different projections, even though the data still remains the same. One other example I'll show you, just to compare two different projections. So these are two different projections on top of each other with the same data, the world map, and how different it can be when you show it on different projections. Let's say I'll change it to maybe this. Oh, this doesn't show. This is also. Yeah, maybe this one. Or let me just. Yeah, this one. This is like a star kind of a projection that we are doing, and how the map has been changed. Yeah, so once we have this projection, we need to create paths that are going to make these boundaries of the map. So that is done using a D3 function called geopath. And let me just show you an example out of it. So right now we have a map layer, and on top of it, we want to show these different boundaries on the map. So we're going to use two different layers, that is a map layer and a city layer. So the map layer is being called first, so it's gonna render first, and on top of it, the city layer will be there. So we again call the SVG, we select the SVG, we get the width and height of SVG, we do the projection as we did previously. And then we can create these geopath on the projection that we have created here. And then we're gonna call the JSON file with the US states in it. And finally, we're going to bind the JSON file on the map layer. So using the map layer, and then we're going to select the data with the JSON.features, that is from here. And then finally, we're going to get something like this. with the different boundaries of the states. We can have different options here. We can zoom, make different settings for the zoom. So the scale can basically be used to show the map size on your screen. Maybe we can set it to 1000, which is going to increase the size. Let me show it on a different page. Okay, I can show it here. Yeah, so it's gonna increase the size. You can decrease it, whatever you want to do with it. Let me just set it to, let me just show you very small. So this is like very small, which is not good to show. Yeah. Can anybody tell me why we have this await keyword before we actually call the JSON? Yes, yes. So because also we have this function as asynchronous. So it's going to create a separate thread and it's going to run kind of like in a background. And we want to wait for the wait function to run before we actually load the data. So yeah, we use this await keyword in that case for our asynchronous function. Yeah, then we can also have these lat long lines on top of our visualization of the map. So it can have these lines, but honestly, I feel that these are not really required. Maybe it's required, but I have not used it ever before. So yeah. Any questions till now? Okay, cool. Yeah. So we have this map, but we haven't done any visualization till yet. Like we have a data and we want to show how it's being visualized on this map. So now we're going to do that using markers by adding markers to on top of our D3 map that we have created here. So for this, let's look at an example where we have the population of different cities of US. And we want to show this population on top of a D3 map. So we're gonna do the same thing. We're gonna select the SVG with height, do the projection, scale it, make the position of the projection that we are doing, set the path to create the boundaries, then load the states and bind it together on the map layer. And finally, we load the data here using the CSV file that we have. And we put it on the city layer because we have the map layer first, and then on top of it, we have the city layer. So we're gonna select the city layer, and on top of it, we're going to make circles. So here, what we are trying to do is we make the circles based on the size of the population we have of different cities. So we load the data from the data that we have here in this city layer, and we're going to put all the circles. So we're going to set the X position as the longitude and Y position as the latitude. And the size of the circle basically shows the population. And then we're going to style it with like a fill color with steel blue and opacity we can set. So this is how the population will look like in different cities. So you see the population here is pretty high compared to maybe here. Can somebody tell me what this function is doing? And why do we have, I mean, basically my question is, why can't we just do d.long to show the exact X position and d.lat to show the Y? Yes.
I assume that the projection function is both of them. So
Yeah. Yeah, and it returns both of it. So we need to put 0 index and the first index to show it. It's very obvious. Also, let me just put it on this spec and show you the data here. So this is how the data looks. The population is a string. So it makes sense we convert it into integer format. But the lat long are also string, but we haven't converted it into integer. Why? Can somebody tell me that? I think it might be possible that way, but the thing is, I looked into the JavaScript, but it can do automatic conversions. So even though if I do not have parse int here, it's still gonna plot it because it's doing automatic conversion. Yep, and maybe we can just do it this way as well, where we can say parse in of the projection. It still works this way. Any questions till now? Yeah.
I don't understand why the zero index after the projection call.
So the projection call takes both latitude and longitude, and it returns the both information that we want. So the first index has the longitude information, and the second index has the latitude information. So the 0 index is showing the longitude, and the 1 is showing the latitude. Any other question? Good question. Did not think about it. I think it cannot parse it that way. Let me just give it a try. If it works this way, I think it doesn't work. Oh, yes, right. Yeah, it's gonna make it on it. Yes, yes. Yeah. So you see, it's just here, some clumsy stuff, because you haven't positioned it based on the projection that we have here of the map. So you need to set it based on the D3 projection that you have for the map. So the projection takes two arguments, the latitude and the longitude. Any other question before I move forward? Okay. So let's look at another example where we want to create a color map. We want to color the states based on certain information or certain value that we have using D3. So this is a data we have of the agriculture output based on different states. So we're gonna do the color plot. So we're gonna do the same stuff that we have done, projection, and then set the path. And then we're going to set the color range that we want for our data values, which is done using the scale quantize function that we have. We load the JSON file, and then we load the state data like we loaded before for the previous example. And then we set the color of the range of the color based on the minimum and the maximum value of the agriculture output that we have, sorry. Yeah, so it's gonna be the minimum of the state data that we have, and the function is going to return the value of the data that we have. So it'll be the minimum and the maximum. That will be the range of input domain color that we have, not the range, I should not say that. And then we create a dictionary out of it, of the data that we have, and we just convert all the string values that we have of the agriculture output to float and save it in the dictionary that we have created here. Then we are going to look, so why do we create a dictionary here? Is because we already have the map JSON and then the city JSON layer that we have created. And on top of it, we are creating another CSV file, which has some information. So just to make it easier to access, we are creating a dictionary. So you can totally go without a dictionary as well, if you want. And then we're going to get the feature out of the dictionary that we have created here. And we're going to put it as the value that we obtained from the dictionary is stored as a feature in the JSON file that we have. And this feature is now can be used later to finally show the output where we are binding the data with the JSON file that we have. So now what we can do is we can style our visualization or style our map layer using the property that we've just inserted in the JSON file based on the color. So this is what you get after that. Let me just see. So for example, here all the states have different values, but let's say if we do not have a value and we have a null value for certain state, so we can just do something like this. Maybe we can just give it a static color. Else we use the color based on the color property that we have. So since all the none of the values were null, so we do not have any flag visible here. But in your, let's say you're doing a homework, you might end up getting such values. So you might want to use this. Let me see if something. Okay, any questions still here? Okay. So these are all data maps. Now we'll go forward to street maps. So as I've discussed before, the street maps can be used to show certain street view, and it can be used to show a position on your map, a specific location on your map. And we do it using the Google Map APIs because D3 doesn't have it, and we can do our D3 visualization once we have the Google Map API on in our script. So one advantage of using street maps is that we can zoom in, zoom out on the street or of the map that we have, because this is not possible here. You cannot do zoom in, zoom out options here, but you can do it here definitely, and you can pan through it. So how to get the street maps, we just need to have an API key that from the Google Map, and then we can load that key on our JavaScript. The JavaScript, we can load that JavaScript API on our script, and then we can create div elements with an ID that will hold our map, and then we can call the google.maps.map to endpoint to create a map inside of a newly created div that we have. So how it works, I'll show you. So let's say we have what we are going to do is we're going to create a map class with the maximum height that we have, and then we're going to create a div with the ID of map, and then we're going to create a map container that is going to contain the map that we have, and Then we can set different options like where to position that particular map, the map container that you have, with different zoom options. The D3 provides different zoom options, which I'll show you later, with different map type ID. Let me just comment it out for the time being. And then we can create a map object with the map container and the different options that we have set. Finally, we can put the Google Map API key that we have generated in the script tag, and we can obtain the street map out of it. We can just zoom in, zoom out. Okay, how will I zoom out? Yeah, and we can pan through it. So we have different zoom options in D3. So the different zoom levels are like 1 is for the world, 5 is for the continent. Here I've showed you the city with zoom level 10. We can have 15 for the street and 20 for the buildings. So for example, if I set it to 15, you'll see something more like that you see in your maps. Yeah, so you can get it from here. So here's this whole process how to get it. So you can just get the map API and put it over there.
So when it comes to the value of the term, can you use various returns for like the in-between stuff, or then you have to use those specific maps?
I think you can do that. I'm not sure. Let me just try. Let's say 17. That's what you want to know. Okay.
Yeah, so that's the closest.
Yeah, let me just reduce the speed to see if the difference is coming up. It was initially 15. Yeah, so it's a much more zoomed in version. So you can, yeah, definitely do that. And then you can set the map type ID. There are different map type IDs as well available in D3. So these can, where did I? Yeah, so you can have different map types, the ID that you can set, like a road map, a satellite, hybrid, or a terrain. So here we have used a terrain ID. So let me just do 10. So this is the terrain view of the same street map. Any questions till now? Cool. Yeah, so this is the same thing. The map object will have the map container that we have created with different options. And then these options can be, and then we can set the map with whatever zoom level that you want or the map type that you want. Okay, so then you can also style your own maps instead of using what is available. So you can style your own maps. This can be done here. I'll show you. Okay. Yeah. So you can style your own map here where you can select how much density of any particular feature that you want to set it to. Let's say you want to set it to little lesser of roads with lesser landmarks, more labels still. And then you can select the theme. Like for example, you can select retro, dark, night mode. And then you can just click on finish. This will generate this JSON file. And you can just copy the JSON file or copy the URL and put it on your script to use this JSON format. So you can set your own map style and then use it for your visualization. So once we have these street maps, we want to do the D3 visualization on it. So to do the D3 visualization, we need to use overlays. So overlay so the overlay consists of the overlay view, which is a constructor. And then you can have different methods in this, like the draw, for example, like the way we were trying to make certain changes in the maps. So it's just deleting and making a new map. So it's kind of like an update that you're doing on your map. Then you can have a get map, which will return the map or the JSON file that we have created. And then you can set a map to whatever JSON we have generated for our visualization that we want. And once you've set the map, you can have different panes on it, and you can add projection. Then you can use on add to show different projections, and you can remove whatever map you don't want to use, the JSON format that you don't want to use. On the map panes, you can have different object specifications like the float pane, map pane, marker layer, and we're going to use overlay mouse target in an upcoming example. For the map projection, canvas projection that we are doing, we can have different methods here as well. For example, you can have the latitude, longitude converted to the container pixel. Okay, this is the max size. Yeah. So you can set different options here for the projections. Okay. So let's just look at one example where we are trying to create the street visualization on top of a street map. Here is one data set. Okay, before I move forward, any questions? Okay, so here is one data set which is of the UFO sightings in different states and countries with their date time and the duration for how long they've been sighted. So how we're going to do is we're going to create a map layer with the 100% width and height. Then we're going to create another map class, UFO class, and set the position. And on top of it, on top of UFO, we're going to create its own SVG. So you might want to create multiple SVGs when you work with it, but it's really not recommended to do that way. But here is just one example. So I'm using one SVG here. And then we're going to create this div with the map ID. And we're going to pass our Google Map API key here. And then we're going to create this function called Google Map with the Google Map style that we have created before with our own style that we have created. Then we can set different zoom different options for this map with the zoom, and we can position it. We can set the type that you want. And then we're going to add styles to it from the Google Map styles that we have. And then we're going to create a map, Google Map, on top of the map class that we have created with the different options that we have set here. And then we're going to load our data in the data variable, and so we're going to plot it for just the US, the country US. So we're going to filter our data based on the country, d.country equals to US, and we're going to look at just first 200 such US data that we have. Then we're going to create the overlay, the D3 overlay that I've been talking about using this Google Maps.overlay view. And then we're on top of it, we're going to call the onAdd function where the properties of this function will be added on this overlay. But we're going to set a layer with the different panes and overlay mouse target method on top of the pane. And then we're going to draw on top of our overlay with the projection that we have created. And we're going to set small circles based on the duration of the UFO sightings that we have seen. And then we are going to create a marker on all of our SVGs that we have created before and put the data with whatever data we have got from here. And then we are going to put a marker on, we're going to enter the marker on our SVG. And then we're going to append those circles. Finally, we're going to, so this is how you're going to set the marker with different options. And then we're going to make the shape of the marker, the circles that we are creating based on the shape that we have, the color of the marker or the circles that we are creating based on the shape we have. Let's say, for example, if we have a fireball shape of the UFO sighting, so it's gonna be green, otherwise it's gonna be this other color. And yeah, then we're going to just add those information. We're just going to do a projection of the different latitude, longitude information that we have. And this is what we end up getting with different size of circles representing the duration and the colors representing the shape of the UFO that has been sighted. So you can see this is the, let me just show you, since we have selected the GeoAlbert something, I forgot the name of the projection, which will handle the Hawaii region. So we have one in Hawaii as well. We can zoom in, zoom out. We can move through it, and we have just selected US, so it's just the data for the US. Yeah.
Is it possible to modify when you zoom in, so you can aggregate data?
Can you say that one?
Like when you're zooming in, zooming out.
Yeah.
Is it possible to be able to receive like a callback so you can aggregate or spread the data? And for example, when you really zoom out, you see less circles, and as you zoom in, you only see the circles that are in that area.
Yeah, I think if we have such data, definitely.
Actually have to implement it yourself. Okay, you can, have a data set that has state and county level data, right, and then you check the zoom level and then you switch to a different resolution, right? So if you look at a county level data set and you zoom out far enough, you know how far you zoomed out, right? And then you can switch to a state level data set.
Or calculate it.
Or calculate it on the fly, but this, you have to do this.
More questions? Yeah, I will appreciate if you ask me questions. This looks like a very silent class. Okay, yeah.
Is this another example of a bad map visualization?
I don't think so, because you have lot of different small cities as well. Like it's showing the position where, see, even for, let me just zoom here. Even in, like, let's say any of the state, Oklahoma, we have sightings here, which is being visualized using the latitude and the longitude information that we have in our data. Like here, I'll show you, we have latitude and longitude information. So it's showing the exact position on the map. So I don't think it's a bad visualization, because you cannot have every lat long information on any other visualization. Maybe it's there might be better options. I haven't thought about it, but I think wherever you have spatial information, it becomes easy to show it on map, where spatial information is of some importance. I can argue that maybe this is not a very good visualization. Maybe it's there, and Alex will kill me after that.
We'll talk about these nuances.
Okay.
Generally, of course,
Yeah.
if you're voting data on a map like this, like space doesn't go right.
Mm-hmm.
So there's cartograms and other approaches.
More questions? Yes.
Modify geographic data, say a map of the US that has size, track to populations. Are there projections that accommodate that instead of those custom libraries, or is it something?
I think these are inbuilt in the library, the JSON files that are coming from this library. So I don't think we can change the projections, but probably if you can work hard to make your own library like this and make your own projections, I guess.
Is there a question? Can we say that?
So, I've seen data where it shows, like, say, voting records for the states. Yeah. And then Democrats and Republican seats. Fast, see it red in the maps. But then they have a comparison data, comparison map, and instead of mapping geographical size to size in that population data to your geographical area, and it shrinks down to small populations. Is that something?
So, yeah, we'll talk about this in the maps lecture, but the short answer is, this isn't part of any of the projections here because it would be a dynamic projection right based on the size. There's algorithms that that kind of like do that out there, but they're not implemented in and probably what you want to do rather is you want you've probably seen hexagon maps, right? Where you, for example, have all the congressional seats in California made out of 50 hexagons or however many votes California has. And so they're approximately geographically positioned. But the way this works is that somebody probably creates the hexagon grid in Illustrator in the background and then makes each of them addressable. And then you map data onto that. That's how you create this custom.
Yeah.
So in that last example, both sides that
Yes.
that visualization talked about a little bit at the start, how like visualizations aren't that useful in certain contexts because you know where certain big cities are. Sort of related to that, I noticed that in that visualization, like zoomed out, there's a big data point that covered like the end of the United States, I think. Like we all know it's the United States, obviously. Is that like a bad thing that happened in the first place, or does it depend, or?
So you're basically asking when we zoom out, we're seeing a big blob of data.
Yeah, and it covers like a label. Granted, it's not a very important label because we all know it's the United States, but like in principle, that's something that we should avoid even when it's obvious.
So yeah, I mean, but we can still show more data when we zoom in for that particular visualization. But if we are just showing it maybe just for different states, then it might be a bad visualization to show. I hope this answers your question.
Kinda.
Okay, maybe let me just open this.
Yeah, like right there, the end of the United States is covered by that. The middle where it says United States, the end is covered. Like that, it seems unimportant, but in principle, like with that, like the points of this, so to speak.
Okay, so because we're using different layers of like the map, the US states. So when we render these layers, it's on top of each other. So that's why it's getting covered. But since we can set the opacity, I think that still can be gone. So if you like the opacity here should be set somewhere.
Maybe a more general answer to your question is overplotting is a problem with maps. So you get into this issue a lot, especially, you know, things happen where people are, and there's like Eastern Seaboard, Mississippi dense, right? So I think that this particular problem, like overplotting a label in a Google Maps isn't really one because you can zoom in, right? So, and then you would see the label there. And it's like, whenever you put a marker on map, you include something, but if you have it in the map, you just something and then see the details if you want to. But generally, this is like a big problem, and this is one of the reasons why we try to, why I advocate for not using maps too often if you have very dense and populated area, very dense clusters, because then you will get a ton of overlap.
Is it possible to change the layer so the data that we're rendering is below the text layer, so the text will be above?
Yeah, but can you show back the map again? See there's lots of circles underneath emotion stuff there, and you don't even know what it is you're missing. So you can fix this with transparency, but it still will be completely resolve the problem. But at some point, you're gonna get some overlap.
Okay, thank you, Jyoti.
There's one.
Hold on.
So those are the UFO with a different shape that has been cited. So I've showed you here. We have set it so we're basically filling the circles based on different colors. This is the green one. This is, I think, that's orange or yellow. I don't know. It's different for my so you can set it based on the shape that you have obtained. So if it's a fireball, it's green. Otherwise, it's orange color, yellow.
It's the other way around, like the reds are the fireballs.
Okay, maybe I'm wrong then. Maybe I'll just look for this color. Yeah, I think it's the other way around. Yeah, sorry. Don't know what this color is. More questions?
Okay, let's take a 5-minute break, and then we'll continue at 3:03 with the Marks and Giles.
Should I just stop the share?
Yeah.